This video will cover Section 3.1 Relations and Functions, Part 2, Day 1. Students will be able to identify the domain and range of a relation with interval notation. First, let's review interval notation. Interval notation is used to represent a subset of numbers on the number line. It represents all the numbers that are between those two numbers, and the type of interval that we use depends on whether it includes the end value. So what that means is if it includes 0, we would use a bracket, and if it includes 20, we use a bracket, versus if it does not include 0, we use a parentheses, and if it does not include 20, we use a parentheses as well. The following table summarizes which type of interval to use for your graph. If it includes a number, then we use a closed circle, so a circle that's shaded in. And when we do that, we use a bracket, so it's one of these two. Versus if it does not include the number, which is shown as an open circle, we would use a parentheses. And the type of bracket or the type of parentheses depends upon which end of your interval you're talking about. Now in this example, we have to indicate the range of the numbers. So first we want to identify the key numbers of our graph, which are 0 and 4, since they're the limits of the graph. So I have a 0 and a 4, and they would go on both sides. Then I'm indicating whether or not it includes the number. So first, there's a closed circle here, which indicates it does include the number, which is a closed circle, so I would use a bracket. So I have a bracket here. On the other side, there's an open circle, indicating it doesn't include the number, and whenever I have that open circle, I use our parentheses. So I have a parentheses here. So my interval is that it includes 0 and does not include 4. If we look at the examples below, they all spread from 0 to 4. However, the interval type truly just depends on whether or not it includes the 0 or the 4. So whenever it includes the number or has a closed circle, that means that we're using a bracket. So we'll notice in the second one it includes 4, so I have a bracket here. And the next one, it includes 0 with a closed circle, so I have a bracket around the 0. And the bottom one includes both the 0 and the 4, so I have brackets around the 0 and 4. Versus when it does not include the number, or is an open circle, we use parentheses. So the first example does not include 0 or 4, so you would use parentheses. The next example does not include 0, so we use parentheses by the 0. And the third one does not include 4, so I have parentheses by the 4. So we see how even though it's always from 0 to 4, the bracket type is dependent upon what the graph looks like. In these examples, we're going to write an interval to represent each graph. So for the first one, I'm going to first pick out the numbers that are important. So I have a 0 and a 10 is the range of the numbers. I'm going to put 0, 10. Then I'm going to determine the bracket type on each side. So the first one, I have a closed circle indicating it includes 0. And when I have a closed circle, I use a bracket. So I can put a bracket around the 0. And then for the other side, I have a closed circle at the 10 indicating it includes 10, which means that I would use a bracket as well. Then for the next example, my important numbers, it ranges between 0 and 9. So I would have 0, 9, and then I'm determining the bracket type. So I notice that I have an open circle at 0, and when I have an open circle, so it doesn't include the number, I use a parentheses. So I have a parentheses around the 0, and then again, similarly, there's an open circle at 9, which means it doesn't include the 9, so I have a parentheses at 9. For the next example, it ranges from 1 to 8. So I'm going to write my two numbers as 1 comma 8, and then I'm going to write my bracket types. So the first one, I have a closed circle indicating it includes 1, and when I have the closed circle, I use a bracket. So I'll put a bracket around 1, and then for the other side, I have an open circle at 8. When I have the open circle, so it doesn't include the number, I use parentheses. So I put a parentheses around 8. For the last one, my two important numbers are -5 and -1. So I'm going to write -5 comma -1, and then I'm going to indicate the bracket type. So the first one I have an open circle at -5, so it doesn't include the -5, which means I would use a parentheses. And then the next one I have a closed circle at -1, so it includes the -1, which means I'm going to use the bracket. For these examples, again, first, let's indicate the key numbers. So I have -2 and 4. So I can write -2 comma 4, and then I'm going to indicate the bracket type. So the first one I have a closed circle at -2, indicating it includes the -2. When I have the closed circle, I use a bracket. So I put a bracket around -2, and then I have an open circle at 4. When I have an open circle indicating it doesn't include a number, you use a parentheses. So I put a parentheses around the 4. For the next example, my two important numbers are -3 and 10. So I write my numbers as -3 comma 10, and then I'm going to determine the bracket types. So for the first one, around the -3, I have an open circle, and that means it doesn't include the number, so I use a parentheses. And then I have an open circle again at 10, which indicates I don't include the 10, so I would use a parentheses. For the next one, my two important numbers are -1 and 8, so I'd rewrite -1 comma 8. Then I'm going to determine the bracket type. So the first one, I have an open circle at -1, so it doesn't include the -1, so it's a parentheses. And then I would have a closed circle at 8, meaning it includes the 8, so I would use a bracket. And for the last one, my two important numbers are 0 and 8. And then I'm going to determine the bracket types. So first I have a closed circle at 0, indicating it includes 0. So I put a bracket, and a closed circle at 8, indicating it includes 8. So I put a bracket as well. Now let's review domain and range. So domain is all the x values of a function. And you can think of it as how far to the left and right a graph extends. So first, the domain here extends from this open circle at the 3. If I were to draw a box around my function, it extends from the open circle at 3 all the way over to here, where I have a closed circle at 1. For the next one, this just keeps going forever and ever, so my domain would extend forever in both directions because of the arrows. Now the range is the y values, and that's how far up and down a graph extends. So if I were to draw a box around my same first function, we can see that the highest it goes is this open circle here. So I would have an open circle there, and it extends to my closed circle down here, showing the range from 0 to -4. The other one, the range continues forever and ever because this graph never stops. So my range would be all the possible y values. In these examples, we're going to identify the domain and range of each graph in interval notation. So what we're first going to do is we're going to highlight around the limits of this graph. Then we're going to first identify just the domain. Now the domain is how far to the left and right it extends. And we can see that our domain is limited on the left by this open circle up here. So the furthest x value is this 16 here, and it extends all the way across this closed circle here. So I put a closed circle at my 16, and the domain indicates all those numbers in between. So my domain would be from negative 16 to 16. And again, because the first one has an open circle, and we know when we have an open circle, we use a parentheses. I would have a parentheses around the negative 16. And then whenever I have a closed circle, I use a bracket to show it includes the number. So I have negative 16 to 16. Then the range is the spread in the possible y values. So the lowest possible y value is from this closed circle down here. So I could range from this closed circle here all the way up to this open circle up here. So I would have an open circle at 20, and it's all the numbers in between. So my range would be from the lowest possible y of negative 20 to the highest possible y of 20. And again, I'm going to fill in the appropriate bracket types. So since by the negative 20, I have a closed circle, I would use a bracket. And then by the 20, since I have an open circle, I would use a parentheses. For the next example, I'm going to do the same thing. So I'm going to start by highlighting the edges, so as far as this function can go. So my highlighted box includes everything, and then start by identifying the possible x values for my domain. So if I look the furthest to the left it stretches is this open circle here. So I can put an open circle, and then the furthest to the right is this closed circle, or the open circle right here. So I put an open circle here as well, and it's this area between. So the two numbers I have are negative 24 and 0. And then for my bracket types, since they're both open circles, they would both have a parentheses around them. Then for my range, I want to identify the lowest possible y value, which is this same spot as well. So I would have an open circle here, and then my highest possible y value based on this is the edge of this box over here at 12. I'm going to have an open circle there, and it's this distance between. So my range, the lowest y is 0, the highest possible is 12, and since these both have open circles, they would have parentheses around them. Now we're going to go through the same process for these next graphs. So if I draw my highlighted box around the possible values of the graph, I'm going to identify the limits of each by starting with the domain. So my domain is the x values. The furthest possible x value is right here, which is an open circle. So I'll have an open circle at negative 4. And then the farthest to the right it goes is indicated by this 3. So I have a closed circle at 3. So I can highlight this area in between. And now my two key numbers are negative 4 and 3. Since I have an open circle at the negative 4, I would use a parentheses. And since there's a closed circle at this 3, I would use a bracket. Next, for the range, my lowest possible y value is indicated by this closed circle here. So I put a closed circle at the 3. And then the highest possible value doesn't have, it's just indicated right here and there isn't a point. However, we can assume that it includes it since it goes through this point. So I can put a point at the 4. And I would draw in that my range is this whole area of the graph. So my range is from -3 to 4, and since they both include the numbers, or have closed circles, I would use a bracket for both of these. For the next example, I'm going to start again by drawing my box around the possible values of the graph, including all the highest and lowest points. And then I'm going to start with my domain. So the furthest to the right, or the left the graph goes, is this point right here. So I can put a closed circle at -5. And then the farthest to the right it goes is represented by this closed circle here. So I can put a point at this 4. So my domain goes between these two numbers. So the key numbers I have is -5 and 4. And since it includes both points, or they both have closed circles, I would put a bracket around both sides of the graph. For my range, my lowest possible point is shown by this closed circle here. So I can put a closed circle at -5. And then the highest possible is similar to the last problem where I don't actually have a point, is right here, but we can assume that it goes through this because it includes that point since there's a line through it. So I can put a closed circle at 5. So my range goes between these values. So my range is from -5 to 5. And since both of them are closed circles that they include it, I would have a bracket on both sides. For the next examples, I'm going to again draw my box around the possible values of the graph. And then I'm going to identify my domain. So my domain, the furthest to the left the graph goes is this open circle. So I'd have an open circle at -4. And then the furthest to the right it goes is this open circle here. So I can have an open circle at 5. And it's this area between the two numbers. So my two key values are -4 and 5. And since both of these are open circles, I would include a parentheses on both sides. Then for the range, my lowest possible value is given by this open circle. I would have an open circle here. And the highest possible value is right here. And it doesn't include a point, however, we can assume it includes that value because it's a straight line. So I could include a point at 3 and it's these values between. So my lowest possible is -3. The highest possible is 3. Since at -3 there's an open circle, I would include in parentheses. And since at +3 there's a closed circle indicating it includes it, I would include a bracket. For the next example, I'm again going to draw my box around the limits of my graph. And what we can see is the furthest possible x value is this point right here, which doesn't give us a point. However, because it's a line, we can assume it includes it. So I can put a closed circle here. And then over here is the same thing. There isn't a point, but it's going to include that point since there's a line through it. So my domain is all of these values in between. So this means the domain goes from -4 to +4. And since there's closed circles at both sides, I would use a bracket for both -4 and 4. For the range, the lowest possible value is here, which again doesn't have a point, but the line goes through it, so we can assume it includes it. So I have a closed circle at the bottom, and at the top, again, the highest value is shown right here, and it doesn't have a point, but it's a line, so we assume it goes through it. So I'm going to put a point here, and my range is all these values between. So it goes from -3 to +3, and since both of them include closed circles, I can use a bracket on both sides of the range. In this example, we have to determine whether it's a function, then identify the domain and range of each graph in interval notation. So first, in order for something to be a function, it has to pass the vertical line test. So in the vertical line test, what you would do is you want to take your vertical line and move it across the graph to make sure it only ever passes it once. And I can see that if I take my vertical line and I cross it, it only ever crosses the graph at most once. So we can determine that this passes the vertical line test. So this is when it asks if it's a function, your answer is yes, because it passes the vertical line test. Then we're going to do the same thing we did for domain and range, like we did on the previous slides. So if I highlight around my graph to show the whole function, the furthest possible value to the left is this open circle. So I have an open circle at -20, and it's the open circle on the right. So I have an open circle at 10, and it's all these values in between. So your domain goes from -20 to 10, and since they both include open circles, you're going to use a parentheses on both sides to indicate it doesn't include the value. Then the lowest possible value is right here, and there's a line through it, so we can assume it includes the value. So I can put a closed circle at the origin, and the highest possible value is shown by both of these points. However, they are both open circles, so I can include an open circle at the top. So your range goes from those values. So the range, the lowest possible y is 0, the highest possible is 24. For the 0, since it includes that value with a closed circle, you'd have a bracket. And for the 24, it's an open circle, so it doesn't include it, so you'd use a parentheses. In this last example, we again have to determine whether or not it's a function, and then identify the domain and range. So for this first example, if I move my vertical line, what we should see is it passes it once, but as soon as I get to here, it starts to pass it twice. In all of these various locations, we can see it's passing it 1, 2, even 3 times just within this one point. So I can, if I move my vertical line off, so is it a function? And your answer would be no, and your reason is it fails the vertical line test. Then I'm going to identify the domain and range like we did before. So if I highlight the box around my whole graph, the value furthest to the left is indicated by this open circle up here. So I can put an open circle at 3. And the value furthest to the right is the open circle at 24. So I put an open circle at 24, which indicates my domain spreads from 3 to 24. So domain, I have 3, 24, and both of these are open circles, indicating they don't include the value. So you would use a parentheses. For the range, we have to determine the lowest possible value is shown here, and that is given by this point here at 2. I'm going to use an open circle since it doesn't include it, and then the highest possible value is given here. So I'll put an open circle at 14, and our range spreads these values. So it goes from 2 to 14, and since both of them are open circles, indicates they don't include the value, so you would use parentheses.